Hello and welcome to SudoKanard. Here is a triple Sudoku puzzle by German author Thomas Fink, which was featured on the qualifying round for German Sudoku, Deutsche Sudoku Meisterschaft. That's the German Sudoku Championship of 2022. With 89 points, it was one of the bigger pointers, but not one of the hardest. So the rule is that whenever you have a line, the digits on a line must form an arithmetic sequence, which means that the difference between those two digits must be the same than the difference between those two digits, and so on, and the same difference with the same sign, meaning that if I'm going from here to that with adding 3, then I still need to add 3 here. It couldn't be 1, 4, 1, it has to be 1, 4, 7. So plus 3 here and plus 3 there. So that's the rule. And let's start. We can see that this is packed with action, and in particular this block is packed with action. There are 2 lines. So what are the options? We could have all 5 odd digits here and all 4 even digits here. That's an option. And we'll see that this is the solution. The other options would be with 5 digits that they be consecutive. And in this case, those will also have to be consecutive, and they must be all on one end. I mean, if I put intermediate digits, let's say from 2 to 6, in any order, well, in this case that wouldn't work, but let's say 2 here and 6 there, then here I will need to put 1, 7, 8, 9, and you see that I can't make them into an arithmetic sequence because the difference between 1 and 7 is not the same difference as between 8 and 9. So I can't put intermediate digits here, I must put extreme digits. But what are extreme digits? One option is 1, 2, 3, 4, 5. But in this case, the middle digit will have to be a 3 here, and it will clash with this digit. So that's not an option. The other possibility would be 5, 6, 7, 8, 9, but in this case the middle digit that goes here is a 7, and it clashes with this one. So we can see that the construction is really, we can't put a 3 here, we can't put a 7 here, so those are not 5 consecutive digits. They must be the even digits, the odd digits, sorry, and because 3 is not here, 3 is here, so the only possible placement is this one. And here we have 2, 4, 6, 8, all the reverse version of this. So that's a nice start. Let's have a look at this. The remaining digits are 1, 2, 4, 6, 8, and we can't have a 1 because 1 and 2 would need a 3, 1 and 4 would need a 7, 1 and 6 would need 11. So those are 3 even digits. So it must be 2, 4, 6 or 4, 6, 8. So the middle digit is 4 or 6. And we know that 1 is here, together with the missing digit, which is either 2 or 8. And I won't put 4 digits into those cells. 4 digits in the pencil marks, I mean. And something interesting that took me a huge time to see during the contest is that we know that 4 and 6 are here, so 4 and 6 are not here. And on this row, 4 and 6 must both be here. And with 4 and 6, the third digit could be a 2 or an 8 if we move by 2, but 2 and 8 are here, so they are not available, and we are forced to move by 1, and this is 4, 5, 6, with the 5 in the middle. Then we get 3, 7, and 9 here. And we'll see later what happens here in relationship with that. Let's move on to the first column. The remaining digits are 2, 4, 6, 8, and 9. And the same logic applies here. Those 3 digits can't include a 9, so they must be even. And this must be even as well. So we have the sequence 2, 4, 6, 8 in one way or the other. And this 2 or 8 and this 2 or 8 are different digits. So this digit can't be 2 or 8, it can't be 5 or 6, it has to be 9. And this digit now goes into this cell. Let's have a look at this. We can't have an even party here because we already have 3 even digits in this column, so there couldn't be more than 1 even digit. So we move by an odd increment. And this now still has to be an even digit because I add an odd increment. This is odd and this now is even. So it must be the counterpart of this digit and of this digit as a 4 and 6. And this, what can it be? Well, we could have 2, 3, and 4. We could have 2, we couldn't have 2, 4, 6. We couldn't have 8, 6, 4. We couldn't have 8, 7, 6 because there's a 7 here. So this is 2, 3, and 4. So now we have here 8, 6, 4, and 2. This is now 8, 6, 4, and 2. And by Sudoku we get a 9 here. This is 1 and 5. This is 3, 6, and 8. And here we have 1, 5, and 7. So a lot has been going on. And now this has to interact with this. We know that the increment is even. So what can we have? We can have 1, 3, 5 here. Could we have 1, 7? No, 1, 7 is not available because it would put 11 here. 1 and 9 would be worse. So next, let's imagine there's a 5 here. Here we could have a 3 and a 1. We can't have 5, 7 because it would put a 9, and 9 would be here in this case. And 5, 9 wouldn't work. 7, 9 wouldn't work either, so this is not a 9. 7, 7 wouldn't work either, so this is actually a 3. And 7, 3 wouldn't work, it would put -1 here. And negative numbers are not options in this puzzle. So now this is 1 or 5. And this may be removed. And here we get a 1, 5 pair, which means that this will never be 1 or 5. Those are not 3s. Oh, 9 would never be in the middle of a line. The only way 9 could be in the middle of a line would be if we had a line here with an increment of 0. But this is not the case in this very puzzle. This 7 is very constrained. Could be surrounded. It must be surrounded by one number bigger than 7. And 9 is not available. So there has to be an 8. And the other digit must be a 6. And because of this 6, 8 is here and 6 is there. So that's a 4. And the remaining 2 digits are 2 and 6. And here we don't have a 2. This now is 1 or 5 and 2, 7, 9 here. So that's a nice work. And the next place to look seems to be this big line here, this big diagonal line. So there again, with a diagonal line, it will either be all odd digits or 5 consecutive digits. And my memory tells me that we can rule all sets of 5 consecutive digits out. So let's do them. It won't be long, actually. If I start with a 1, 2, 3, 4, this 4 clashes with this. And actually 1 was ruled out by this 1-5 pair. 2 and 3 are impossible. But if I put a 4 or a 5 here, I would have 6 here or there, and it would clash with this. So I can't have an ascending sequence of consecutive digits starting from this. Let's start a sequence of descending digits. But 9 would put an 8 here, that doesn't work. 8 or 7 would put a 6 somewhere here, that wouldn't work, and 6 wouldn't work. And 5 would put a 4 here. We see that all those options are ruled out immediately. So those must be consecutive, no, not consecutive digits, but all odd digits. And we see that 9 can't go here, and we knew that 1 wouldn't go here. So the order is this one. This is not 7, so this is 7. This 3 is not here. This one makes this an 8, this a 1. Is there anything else to tidy up? No, but this line now has candidates 1, 2, 3, 4, 8. There's definitely no 8 in here. It's 1, 2, 3 or 2, 3, 4. But by Sudoku, with this 3 and this 3, 3 must be in the middle. So it's surrounding by 2 and 4. And 1 and 8 must go here. This 4 goes there, and those are 2 and 3. On this row, I still need 1, 5, 7, 8. So 5, 7, or 8. This can only be 7. That's not a 7, so this is 1, 5, or 8. On this row, 1, 5, 6, and 9. So this is 6 or 9. 5, 6, or 9. All 4 options remain here. That's not interesting. This column needs 2, 4, 6, and 9. So this is 6 or 9, and it puts a 2 up there and a 4 down there. And now this 4 is very interesting. I can't put 3 and 5 because of this. I can't put 1 and 7 because of this, so there must be 2 and 6. So this is a 9, that's a 6. And then, so we must be close to the end. The rest is basically classic Sudoku. Here I still need 5, 7, and 8. So this is 5 or 8. 5, 7, 8. 5, 7, or 8. Here I need a 1 somewhere. Oh, and I need a 1 on this part and a 1 on this part, so 1 is here. 5, 6, 7, 8, so this is 5 or 8. Oh, and it creates a 1, 5, 8 triple here, so those are 2 and 3. 5, 6, 7, or 8. I don't see anything to do with that. Here, this column needs a 9. It must go here. This is 2, 3, or 6, but it won't be 2 or 3, so that's a 6. Nice. So that's a 2, that's a 6. That's a 3, that's a 2. No 3 here, so the 3 goes there. This is now 1, 5, or 8, but there's a 1 here, so this is 1 or 8. I get this one here, this 5. No 5 here. I need a 4, it's here. That's a 7. No 7 here. 6 on this row is here. 8, and now this should all unwind. 9, 7, 5, 8, 1. That has to be 9. And this 2 gives the 4, the 2. This is the 4. This 6 now gives the 2 and the 6. The 3, the 2, that's a 1, that's a 5. So that's a 1, that's a 5. 1, 8, 5, 8, and 5, and 8. Very nice puzzle, very pleasurable, with logic that needs to dig a little, but really not that deep. There were really very, very reasonable digs, and I should say that the solving path is very well advertised. It's very well signed. How would you say that? I mean, there are really road signs telling you where to look. And that is really, really neat setting. So thanks, Thomas Fink, for this beautiful puzzle. I just wish I hadn't broken it during the contest, but then this is what I do. So thanks for watching this video, and see you soon on SudoKanard.